Right now, I need to inform you guys of something very, very important. Our Algebra 2 Fall Practice Final has a missing question. Dun, dun, dun. Right? Yeah, missing question. No. We're going to learn that missing question right now. So, on the practice final, we never see this right here. And for sure, this is on the final. So, do me a favor. Let me make some space here. Do me a favor. Copy this down. I guarantee you this question, not exact, but very, very, very similar, will be on the actual final. Okay, so copy it down, and we're going to work through it just so you know exactly what to do on this question on the final. This question's very basic if you understand function notation. This is just the name. R of x is just the name of 3x squared minus 7x plus 1. Now, function notation says that if you were to write this down, r of 5, that technically means the sentence, I want you to take the number 5 and plug it into your x values of the r of x function. Right? That's a long sentence to write as instructions, so it's easier to just write r of 5, and that would imply that you plug in a 5 right here and a 5 right there and you do the math. That's the basic understanding of function notation. Bless you. However, right here, they say evaluate for r of x plus 3. Are you kidding me? So instead of plugging in a simple number like 5, we're actually going to be plugging in a binomial like x plus 3. Okay? So right here, r of x plus 3 is really just saying plug in the binomial x plus 3 wherever your x's are at, right here and right there. So the key to doing this correctly is to rewriting your original function, but with parentheses instead of x's. Let's do that. Let's write down 3 parentheses squared minus 7 parentheses plus 1. I made my parentheses kind of big because I know I'm not plugging in just the 5 or just the 2. I'm actually plugging in a binomial x plus 3. So I'm going to take this binomial x plus 3 and write it right in my parentheses. It's really an Algebra 1 problem once you understand how to set it up. Now you got to distribute, right? Exponents first. I'm sorry, not distribute, but exponents before distributing. So we need to do that binomial x plus 3 times itself. Because of the plus, you cannot distribute the exponents. You actually have to write it twice. Let's do that. X plus 3 times x plus 3. And let's distribute x times x, x squared. X times 3, 3x. 3 times x, another 3x. And 3 times 3 is 9. When I combine the middle terms, I will get a positive 6x. Let me bring down the x squared, bring down the plus 9. I now have a quadratic trinomial. This original binomial squared became a quadratic trinomial. However, we have a 3 out in the front. So let's put parentheses around this quadratic trinomial and bring down that 3 out in the front. So you could rewrite it all if you wanted to show a lot of work. I'm just going to leave it like that for now. I am going to distribute 3 times x squared, that's 3x squared. 3 times 6x, that's going to be a plus 18x. 3 times 9 is plus 27. And now, so far, I've just done the binomial squared and then distributed the 3 to each and every term. There's my answer to this first part. The second part is to distribute the negative 7 into that binomial. So let's do that. Let's take this negative 7 and distribute it. Negative 7 times x, I'm going to write my answer way down here, negative 7x. Negative 7 times 3, write my answer way down here, negative 21. What about this plus 1? Just bring it down, put the plus 1 at the very end. So I've distributed. Now I need to, at the very end, add and subtract, which is combining like terms. So I want to start my answer with the highest exponent term, which is a 3x squared. So that's my answer. 3x squared, and then I have the 18x. I should probably use other symbols like a squiggly underline. 18x minus 7x. What's 18x minus 7x? 11. Positive 11x. And last but not least, we have our numbers. So we have a 27. When you take away 21 from 27, you get 6. 6 plus 1 will take you back to 7. So ladies and gentlemen, this is our answer down here. 3x squared plus 11x plus 7. It's a quadratic trinomial, okay? So I guarantee you there's going to be one of the 30 that's going to be exactly like this. Is it super important? Well, it's one question out of 30, you know? And I honestly think it's pretty easy. It's just distributing and combining like terms. So I did give you several problems to practice of each question on the practice final. So let me do the same for this one. How about you guys try it right now? It's the same problem, just mixed up with different values or different numbers. It's the same exact process. Let's try it. I want to pause it. You guys try it. Here we go. So once again, the trick is to rewrite it with parentheses. 2 parentheses squared instead of 2x squared, plus 5 parentheses instead of plus 5x, minus 3 at the very end, plugging in the binomial x plus 2 right in there. So let's distribute. I keep saying distribute. Let's rewrite it, the binomial times itself. I mean, technically, you're going to be distributing. X times x becomes x squared. X times 2 becomes 2x. 2 times x is another 2x. 2 times 2 is 4. Combine the middle terms. You're going to get x squared plus 4x plus 4. Now, don't forget about the 2 that's out here in the front. So let's put parentheses around this quadratic trinomial, bring down the 2, and then from here it's just a question of distributing the 2 to each and every term, distributing the 5 to each and every term, bringing down the negative 3, and then combining all the terms that are alike. So let's do that. Let's distribute the 2. Let's do that. 2 times x squared is 2x squared. 2 times 4x is 8x. 2 times 4 is 8. And then let's distribute the 5. 5 times x, that's a positive 5 that we're distributing. 5 times x is positive 5x. Notice that I wrote it way down here. 5 times 2 is 10, positive 10. I wrote it way down here. I want to bring down the minus 3 as well. Then it's just a question of combining like terms. So the first part of our answer will be the highest exponent term, 2x squared. Combine this 8x with this 5x. We'll get 13 x's, and then combine the 8 with the 10, that's 18. 18 take away 3 is plus 15. That's my answer for this question. Again, there's only one of these questions on the final, but I think it's too easy to just miss, to skip it. Anyway, I'm pretty much done with this video, but I do want to mention that you're going to be able to use the Desmos app on the final exam, believe it or not. So that really comes in handy. We have all our solutions here. That really comes in handy on these last questions where it says find all the zeros, right? So like even right here on the solutions, I said use Desmos to get, because you're going to be able to use the Desmos app. So maybe right now is a good idea to get the Desmos app and practice with it so you'll be fluent with it tomorrow on the final. Let's actually get the Desmos app and type in this quartic huge polynomial and see how it helps us. So let's do that right now. Let me get rid of this, of the actual work. Let's just focus in on this question 59 just to show you. If you type this in the Desmos, you could put y equals. As a matter of fact, you could even just type it in without the y equals. It'll give you the same exact graph. Let me show you. See, on the Desmos app, I didn't even put y equals, but it gave me the same exact graph. You could put y equals if you want, but here it is typed in exactly the way it is. X to the 4th minus 6x to the 3rd plus 6x squared plus 24x minus 40. And what does this graph tell us? It tells us that there's two answers. So we know for a fact that x equals negative 2, and we also know for a fact that x equals positive 2. So let's keep that in mind. X equals negative 2 and positive 2. And let's write that down right here. X equals positive 2 and x also equals negative 2. So imagine how hard this would be without the Desmos app. Because if I told you find all the answers to number 59, well, you'd have to use the rational root theorem where you would say the multiples of 40 plus or minus divided by the multiples of the leading coefficient. So to make that list of possible answers, it could be 1 or negative 1. It could be 2 or negative 2, 4 or negative 4, could be 5 or negative 5, 8 or negative 8. I mean, the multiples of 40, forget about it. So that's why the Desmos app is so important, because right off the bat, you know 2 answers. These 2 answers guaranteed will work. So if you use synthetic substitution and plug in 2, you're going to have the coefficients 1, negative 6, positive 6, 24, and negative 40. As you go down, you add 1 plus 0 is 1. As you go up, you multiply. 2 times 1. As you go up, you multiply. 2 times 1 is 2. As you go down, you combine. Negative 6 plus 2 is negative 4. As you go up, you multiply. 2 times negative 4 is negative 8. As you come down, you combine. 6 and negative 8 is negative 2. As you go up, you multiply. 2 times negative 2, that's negative 4. As you come down, you combine. 24, take away 4, that's 20. As you go up, you multiply. 2 times 20, that gives me 40. And yes, the remainder is 0. That does not surprise me. Why? Because I know for a fact, using Desmos, that x equals 2 is a solution. Okay, so what could we do now? We could continue to substitute our next answer with the depressed coefficients of the depressed polynomial, right? So let's do that. To break it down further, let's plug in that negative 2 using these coefficients, the 1, the negative 4, the negative 2, and the 20. Again, as you go down, you combine. 1 plus nothing is 1. As you go up, you multiply. Negative 2 times 1 is negative 2. As you come down, you combine. Negative 4 and negative 2 is negative 6. As you go up, you multiply. Negative 2 times negative 6 is positive 12. As you come down, you combine. Negative 2 and 12 is 10. As you go up, you multiply. Negative 2 times 10 is negative 20. And once again, no surprise, the remainder is 0. By us using Desmos, we found these 2 answers. And now we could get to a quadratic trinomial. This quadratic trinomial is x squared minus 6x plus 10. And they want us to find all the answers. Now, when we used Desmos, we saw that it only crossed twice. That means that your other answers are imaginary. So we know, we're going to be using the quadratic formula to find those other answers. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And when we use the quadratic formula, please use parentheses so you don't make any mistakes. B squared plus or minus square root of, b squared minus 4 times a times c all divided by 2 times a. So the b value is negative 6, the a value is 1, the c value is 10. Plug in a negative 6, plug in the a value of 1 down there and up there, and the c value of 10 right there at the end. Starting with the discriminant, negative 6 squared is 36, and minus 4 times 1 times 10, that's negative 40. So you have 36 take away 40, you're going to end up with the square root of negative 4. We have a plus or minus a positive 6 out here, all divided by 2. Now we should all know that the square root of negative 4 is what? 2i. Running out of space here. So we have, let me write it over here, 6 plus or minus 2i, all divided by 2. And you could separate that denominator, the divisor of 2, into each of those terms. So you could have 6 divided by 2 giving you 3, and 2 divided by 2 giving you 1. So your final answer will be 3 plus or minus I. So those are your 2 other answers, and that makes total sense. It was a 4th degree equation. You have 2 real answers, 2 imaginary. You could have also reduced right here, just reduced by 2 on all your terms. I need to get the 3 plus or minus I also that way. So that's about it with regards to my final message on reviewing for the final. If you need help, you have all those other videos previously posted that goes through every question on the practice final, okay?